Next question. When light is scattered by a molecule, the frequency of the scattered light is changed. This phenomenon is called Rayleigh scattering, Raman effect, photoelectric effect, Rutherford scattering. So the answer is Raman effect. Okay. So when there are some particles, when the particles in the air, suppose molecules in the air, when the light enters that medium, it is scattered. It is scattered. This light is scattered by the particles and the frequency of the scattered light changes. And that is given by Raman effect. So this scattering occurs due to the difference in wavelength of light as it enters from one medium to another. Okay, this scattering occurs because of the difference in wavelength of light when it enters one medium from the other medium. Okay, so this is known as a Raman effect. The Raman effect is scattering of light by a molecule. Then Rayleigh scattering. Rayleigh scattering actually gives the relation between intensity of light and the wavelength of light. Rayleigh scattering is a relation between, it gives the relation between intensity of light and the wavelength. But the change in frequency of the scattered light, that is given under Raman effect. That is given under Raman effect. So that is also a direct question. Next question, next physics question we'll see. So all these questions we have seen is only up to your 9th and 10th level questions. Not other than that, they have not asked anything. So these are direct questions from your 9th and 10th NCERT textbooks. We'll see next physics question. Twinkling of stars. Twinkling of stars is due to particular frequencies of starlight, reflection of starlight from oceanic surface, atmospheric refraction starlight, magnetic field of Earth. So the answer is atmospheric refraction of starlight. Okay, so I'll explain the phenomena. Light from the star travels very long distance before it reaches the observer's eye. Okay, so when it travels this large distance, it is traveling through different layers of air, and that will be having different densities. As a result, this light will undergo continuous refraction when it travels through the air, which is having different densities. Okay, so when the density changes, there happens the atmospheric refraction. Okay, so for an observer who is looking at this star, it appears like the star is twinkling. Actually, what is happening? Refraction, atmospheric refraction of the starlight is happening. Okay. Next question. Which one of the following cannot be the unit of frequency of sound wave? So frequency of sound wave they are asking. So frequency, what is frequency? Frequency is actually 1 by time period, isn't it? Frequency is actually 1 by time period. So second inverse is possible because 1 by time period, no? Then hertz, obviously it is unit of frequency. Minute inverse, if time is given in minute, it can also be unit because 1 by time period, isn't it? Now what cannot be the value? That is decibel. Cannot be the unit, that is decibel. Because decibel is the unit of loudness of sound wave. Decibel is the unit of loudness. Loudness of the sound is measured in decibel. Loudness or intensity of sound is measured in decibel, and that is not used for measuring the frequency. Other units can be used. Next question. Beats is a phenomenon that occurs when frequencies of two harmonic waves are equal, far apart, multiples of each other, nearly same. So here the answer is nearly same. Okay, so beats is a phenomenon that occurs when frequencies of two harmonic waves are nearly same. Okay. See here, I have a wave which is having some frequency. Here we have another wave. This is wave 1. This is wave 2. I am going to draw. Suppose they are having almost same frequencies. Nearly same frequencies. What happens is, at some points, they superimpose each other. If they are traveling in same medium, at some points, they will superimpose on each other. And as a result, what happens is, at some positions, we'll get a very large high amplitude wave, and at some position, we will get small waves like this. Okay, so what happens if we have two waves nearly of same frequencies at traveling in a medium? At some positions, they'll superimpose each other to give positions which are having rise and positions which are having fall. And there is a regular variation happening like this, and that is known as, this phenomenon is known as beats. Regular variation, regular rise and regular fall. That is known as beats. Number of beats per second is known as beat frequencies. Number of beats per second is known as beat frequencies. Okay, so what is a condition for beats to exist? It is when they are having same frequency and nearly same frequency, and they superimpose in a same medium. Then what happens? Some will have, at some points we could see rise in amplitude, some points we see fall in amplitude. And this, how many beats are occurring in a second? That is known as beat frequency. So the answer is nearly same. In this question, answer is nearly same. This occurs when the frequencies are nearly same. Light waves incident on air glass boundaries. Some of the light waves are reflected and some are refracted in the glass. Which one of the following properties is the same for the incident wave and refracted wave? See, when a light goes from one medium to another medium, what happens here? There happens a refraction. Mainly refraction will happen when it goes from medium 1 to medium 2. Now, obviously, when it is traveling from rarer to denser, here it is air glass boundary. What will happen? Speed of the light changes. That is correct. Speed of the light changes. They are asking which property remains same. Speed changes, so that is not remaining same. direction is changing. See, it is bending, isn't it? It is bending. So direction is changing. Obviously, brightness will change. Something which is bright in air may not be bright in glass, isn't it? So brightness will change. The property that will remain same for an incident wave or light is frequency. So when there is a refraction, when the light is traveling from one medium to another, its frequency is not changing. Frequency may depends on the source of the light, and it is not depending on the medium. Not on medium. It is not depending on the medium. On what does it depends? It depends on source of light. Okay, so light waves which are incident on a gas boundary, their speed changes, direction changes, brightness changes, but that does not change its frequency. Okay. Which one of the following statements is true for simple harmonic oscillator? So first option, force acting is directly proportional to displacement from the mean position and is in same direction. Force is directly proportional to displacement and is in opposite direction. Acceleration is constant. Velocity of the oscillator is not periodic. Okay, so let's see this. So a simple harmonic oscillator will undergo a periodic motion, isn't it? Let the displacement will be x is equal to a sine omega t plus phi, where a is the amplitude, maximum amplitude. Then it will, if it is a periodic motion, we'll represent that using a sine wave, isn't it? Phi is a phase, angular velocity is omega. Now, what is its velocity? Velocity is dx by dt, isn't it? Rate of change of displacement. Displacement is x. So that will be a omega cos omega t plus phi, isn't it? Now, what will be its acceleration? That is dv by dt. That is minus a omega square sine omega t plus phi. I'm taking the derivative again 2 times. First time I'll get the velocity. Second time if I again take the derivative, I'll get the acceleration. Now we know F is equal to ma. So that will be m into a. M into a. Acceleration, see, acceleration is having a negative sign, isn't it? Acceleration is having a negative sign. Okay, so that is minus a. So here, this a represents the acceleration. This is coming from the expression, isn't it? So this is, so this a, I'll keep it as capital A, and otherwise you'll be confused. So m into a, acceleration capital A. So that is minus a omega square sine omega t plus phi. So from this you'll understand that force is proportional to displacement, obviously, because force is directly proportional to displacement. But see, there is a negative way, isn't it? So that means proportional but opposite direction. Opposite direction. So that statement is the correct statement. Force will be proportional to displacement and it is opposite direction. Okay. Now acceleration. Let's see, we are coming back to the statements. Okay. So just note down, force is proportional to displacement and is in the opposite direction. Now coming back to the question. So this statement is obviously correct. The statement is correct. We'll see the other statements. So it is in the same direction, that is wrong because we have already proved it is in the opposite direction. Now acceleration is not constant. So that statement is also wrong. Velocity of oscillator is periodic. Velocity of oscillator is periodic. Okay, so that statement is here they have given not periodic. So that statement is also wrong. So the true statement is option B. It is proportional and it is opposite direction. That is the correct statement. Next question. If a ray of light enters from a rarer medium to denser medium at zero angle of incidence, it would. The ray of light enters a medium from a rarer medium to denser medium at zero angle of incidence. It would. Options: reflect back, go straight, turn towards right, bend at 45 degrees. If a ray of light enters from a rarer medium to denser medium at zero angle of incidence, that means like this, zero angle of incidence. So this is the normal. Zero angle of incidence means no angle, it is entering perpendicular. Then what happens? There is no refraction happens. Then it goes straight. If it is from rarer medium to denser medium or denser to rarer, if it is entering normal or at 90 degrees, that is zero angle of incidence or perpendicularly, it will go straight. There is no refraction happens. So the option is option B. Okay. Next question. Mirage is an illustration of only dispersion of light, only reflection of light, only total internal reflection of light, refraction and total internal reflection. Refraction and total internal reflection of light. See, mirage. What is mirage? Mirage means that is a outcome of total internal reflection as well as refraction, Total internal reflection as well as refraction. So let's see what is total internal reflection. Total internal reflection occurs when the light travels from a denser medium to a rarer medium. When light travels from denser medium to rarer medium, and angle of incidence is greater than critical angle. So these are the two conditions for total internal reflection to happen. And obviously, there should be refraction when a light rays travels from denser to rarer medium. Okay.